Welcome to the 38th video in our series about Unix tools. In this video, I will demonstrate how to use the BC utility. The BC utility is an arbitrary precision calculator environment that runs in text mode. Let's do it. So the first thing you might try is the help command. And you can see there's not much help available from the BusyBox version of BC. That's okay. That's why we have the video. If you start BC, I should go back. If you want the standard library, you have to ask for it with -L. If you want strict POSIX compatibility, you have to ask for it with -S. And to check if you're using extensions or not, you can use -W and it will warn you. So let's get started and assume that we want the math library. Okay, and it tells you a little bit of welcome, and it doesn't even display a prompt. You just see the cursor blinking, at least I hope you do. So what can we do? Let's try something simple, right? 1 plus 1, it's 2. 2 times 2 is 4. Let's try something a little bit harder. 2 divided by 3. And you can see it does floating point math for that. And then we've done addition, multiplication, division. Let's try a little subtraction. And you can see it seems to work the way we expect it to work. What about parentheses for subgroups? You know, if you go 2 times 3 plus 4, that's going to give you 10. And 2 times 3 plus 4 should give us 14. It does. So you can see that you can use parentheses just like you do in algebra to override the operator precedence. This makes the BC program do the addition first and then the multiplication. Whereas without the parentheses, multiplication is a higher precedence, so it does the multiply and then the add. Okay, so far so good. What if we want to do something a little bit more impressive? Can we do a modulo operator? Okay, if we know 5 mod 3, we know that you need to do an integer division by 3 and get the remainder. And this is not strictly a modulo, this is a remainder. So we should have 2. And oh no, what happened? What is this? This looks crazy. The problem is your scale. If you want to get an integer remainder, you have to set your scale to 0. And then if we do 5 mod 3, we'll get 2. But then when you do 2/3, you get 0. So you'd have to reset your scale to something reasonable. Let's set it to 15 and do 2/3. If we did scale equal 3 and we did 2/3. You notice it does not round the way you think it would. You would think it would show 0.667. It doesn't. That's just a characteristic of this system. Okay. I'm pretty bored with this so far. It hasn't shown me anything interesting. Let's think about how do you compute some number you might recognize. 3.14. You might recognize that, but our scale is not very good. Let's go with 50 places after the decimal. 3.14 159265355 bop, 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 bop. And there it is. That's computing pi. You might wonder, what is A? And A is the arctangent. We had the -L option to load the math library, and one of the functions it loads is the arctangent. You get sine, cosine, arctangent, and you get E function for exponentiation and L for natural log. So let's try E1. You should recognize that number as E from your calculus class. And then if we did the natural log of this number, it says, I don't understand it. That's because the functions are all one letter. And you can see it's trying very hard to be one. It just can't quite do it. But that's essentially one. Can we raise to a power? One of the things a lot of programs do is something like this, 2 to the 8th. 256, no problem. Can we do 2 to the 8.1? No. Fractional powers are not going to be processed with that power operator. Once you know that limitation, you might be a little disappointed, and you might also ask, well, what about hyperbolic sine or some other esoteric function from the mathematics classes you took, like trigonometry? BC only comes with a few math functions. Anything else, you're going to have to implement it yourself. BC comes with sine, cosine, arctangent, log, exponential, and it comes with a Bessel function as well. I've never even seen the Bessel function, so I don't know how to work with it. But sine, cosine, arctangent, e to the x, natural log, and the Bessel function uses the letter J. We haven't had any variables with this calculator. Even with a fairly standard calculator that you're allowed to take to the exam, it usually has a store and recall button that will allow you to store some numbers. Can we do that with this BC? Sure we can. We can say A equals 2, B equals 3, and then we can say X equals A over B. And then if we just type X, it'll show the answer, 2/3. And if we looked at A, it's still 2, B is still 3, and X is still 2/3. In the classic version of BC, you got 256 variables, one for each ASCII byte. But realistically, you could use A through Z for 26 of them, and then uppercase A through Z. If we type in uppercase A, it says 10, B is 11, C is 12, A is still 2, B is 3, C is 0. So why is A 10? You might wonder. It turns out that this tool can do more than what we've seen so far. But the first thing you want to know is, how do I exit? Use quit. Or the other way is to press the control key and the letter D, which sends an end of file character, and that will also exit the program. So we've started it again. Let's do something programmers need to do a lot, and that's convert between hexadecimal and decimal. So let's say you want a hexadecimal number, base 16, and you have a decimal value. Well, you can set your output base to 16, and then if you type in 255, you'll see FF, just like you should. And if you type in 256, you'll see 100, which is correct. And then we can exit. If we want to go the other way, we can set the I base to 16 and the O base to 10. I is input, O is output. And then we can put those numbers back in. Let's try 100. And it says, I'm still getting 100. I'm still getting FF. Yeah, when you type in this stuff, it gets confusing. Well, it turns out you only want to set one base. Don't set two. So if we do I base 16 and we type in FF, we get 255. If we type in 100, we get 256. And if we type in FFFF, you get that magic number that you used to see in the MS-DOS days, which is probably before you were born. But 65535, which was the maximum number. Okay, we've exceeded our time, but I've shown you all the common features of the BC tool, so you now have a big number calculator when you need it. Thank you for listening.